This is Brianna, Jenni, Michael, and Faris's presentation 2 for Engineering 460. In this video, we will give an introduction to Monte Carlo.
In Chapter 1 of our text, the example used is the integral from 0 to infinity of x to the power alpha minus 1 times e to the negative x with respect to x. While going through the chapter, we use this example and look for the area under the curve of this function. Monte Carlo is used when there is no closed-form way to solve using an integral like we know, so when we are not able to just integrate to find the area.
And now we will talk about evaluating an integral. What does it mean? And why do we consider the simulation of the data points to find the area? And we will discuss the concept of expectation. First, we consider simulating of data points to find the area when we have to find the optimal points on an area with random points. It also allows us to sort high to low, showing which x value give higher y value. Now moving into the concept of expectation, it is basically plugging random numbers and for x according to exponential distribution and take the mean. It also has PDF or PMF, and we know the mean of an exponential is 1.
So what relationship do integrations, probability densities, and fissionable materials have in common? So what they do is they all take stepwise functions in order to create their curve, and with integration we see that using the limit theorem that they actually take small steps in order to calculate the area under the curve, and that's very similar to stepwise functions is very similar to what probability densities are, which determine the likelihood of a specific event occurring, and then fissionable materials are do create a stepwise graph as well. So the statement of we can estimate the value of any integrand no matter how complex the integrand is really important because it shows how powerful Monte Carlo is. Instead of most integrals where you have to follow set formulas and substitution rules in order to integrate things, that really only covers a very small amount of the possible problems that can be solved with integrals. The rest of those are solved with Monte Carlo, because Monte Carlo is the ability to break these integrals down and substitute them with easier to deal with integrals, and it can fit any distribution.
In order to use Monte Carlo to solve complex distribution functions, we must first determine the most appropriate distribution of the input variables and randomly generate a sampling of numbers. These variables are inputted into the analysis model. This analysis model is the function that will evaluate the performance of the model. After the random population of numbers has been generated, the resultant of the function becomes the sample of output variables. The statistical analysis on the output of the model allows for the probabilistic information to be gathered for the complex distribution function to be solved.